Hey everyone, and welcome to section 6.4. It's a good idea every now and then to kind of take a step back once you have a lot of information and take stock of what we have. So we got a lot of different tricks for factoring polynomials, and what we're going to do is look at a general kind of strategy or flow you should follow. So when you look at a polynomial, you want to first ask yourself, is there a GCF? So there's two possibilities. It could either be yes or it could be no. If yes, if you have a GCF, you want to factor it out and turn your attention on what's left. So you're going to consider that part factored, right? And then you're going to be continuing this strategy with what remains. If you don't have a GCF, you want to ask yourself, what does this polynomial look like? And there's a couple possibilities. It can either be a binomial, a trinomial, or maybe it has more than 3 terms. So let's look at what we do in the case that we have a binomial. So you have 2 terms, it's either plus or minus. After we decide whether it's a sum or a difference, we want to look at next, is it a sum of squares, a sum of cubes, a difference of squares, a difference of cubes? What is it? So it can either be squares or cubes. If it's a sum of squares, then it doesn't factor. We discussed that a little bit at the end of the last video. If it's a sum of cubes, then you use the sum of cubes formula. You don't have to memorize it or anything. Really, it's just kind of there for completeness sake. So those are the possibilities. All right, now let's go back to when we have a difference, a binomial difference here in this purple square. We've got to ask ourselves, okay, do we have squares or cubes? And if we have the difference of squares, we know how to factor that. That's one of the special ones. And if we have a difference of cubes, then we know how to factor that. That's another special situation. So that covers completely the binomial stuff. If it doesn't fall into one of these pockets, let's say, you're gonna have to try something else. And it is possible, depending on what the polynomial is, that it doesn't factor. That's always a possibility. So what if we have a trinomial? If we have a trinomial, we have something that looks like ax squared plus bx plus c. The next question is, well, is a equal 1? If a is equal to 1, then you're just doing FOIL backwards. And if it's not 1, then you're going to be doing this AC method, which they're very similar and very much related. The AC method is kind of a generalization of this reversing FOIL. And that covers it for the trinomials. If you can't factor based on these 2 methods, there are other ways of factoring these expressions that we'll get to later on. So that covers the trinomials, and for more than 3 terms, there's really only one option, that is to factor by grouping. And that's something you can try in the other situations as well. But yeah, so this is a kind of visual way to try and figure out what you're supposed to do in a given situation. I know there's a lot of stuff on here, but you start at, is there a GCF, and follow your arrows. All right, first thing I want to do is look to see if there is a GCF. So let's think, 12x cubed y squared. That would be equal to 2 times 2 times 3 times x times x times x times y times y. And then 75xy squared and yeah, we do have some common factors. So we have this pair of 3's, and we also have one pair of x's, and the two pairs of y's. So this is equal to 3xy squared So we factored out this 3xy squared, and look, this is next up. So I don't have any factors that are common among all of the terms. And this has more than 3 terms in it, so we can try and factor this guy by grouping. If we put these two together, and these two, what do I get? Well, that first pair, everybody has a 4x in common. So it'll leave me with x plus 2b. And if I factor out, let's see, 4a, negative 4a, I would get x plus 2b again. And hey, we've been here before. We can factor out that x plus 2b. And we're left with x plus 2b times 4x minus 4a. All right, and last example. Do I have any common factors? Yes, I do. I have the 7, the x, and the y. So this would be 7xy. Y to the 4th minus 1. Now, remember from our rules of exponents that y squared squared is y to the 4th? So actually, this is a difference of squares. Which would factor as y squared minus 1 and y squared plus 1. And you guessed it, that middle guy there is another difference of squares. And that y squared plus 1 is not going to factor. So here we have our final answer. So now that we got that strategy under our belts, what we're going to do is put it into practice for solving polynomial equations up next.